Number 30 is the last stoichiometry problem. So our chemical equation is that sugar turns into methane and carbon dioxide. One sugar produces 3 methanes and 3 carbon dioxides. We are supposed to find the volume of methane that is produced when 1 kilogram of sugar is digested by the bacteria. In order to find volume, I'm going to need to know the number of moles of methane. So I'm going to be using the ideal gas law. But before I can, I have to turn this from 1 kilogram of sugar into moles of sugar so I can find out how many I will make. Well, some straightforward things is that 1 kilogram is 1,000 grams. And by using the periodic table and coming up with the molar mass, I can see that for every 1 mole of the sugar, C6H12O6, that has a mass of 180.16 grams. So that will turn it into moles of sugar. And then the ratio is that I get 3 moles of methane for every 1 mole of the sugar, C6H12O6. So when 1 kilogram of sugar is digested using this reaction, we end up with 16.7 moles of methane, CH4. Now I also know from my equation that the pressure equals 825 torr, which means my R is going to equal 62.4, because that's the value of R that matches the pressure unit of torr, that my temperature is 300 Kelvin, and I just found my number of moles. So the ideal gas law, PV equals nRT, I'm looking for the volume of this methane. So that simplifies to be volume equals nRT over P, which is number of moles, 16.7, times R, 62.4, times T, 300, divided by pressure, which was 825 torr. The volume is going to equal 379 liters.